Alright, so for this problem we must solve for the following theta. We use exact values when possible, otherwise we round to the nearest thousandths. So we have 3 plus 2 cosine theta equals 3 sine squared theta plus 1. We must recognize that sine squared theta is also 1 minus cosine squared theta. So now we have, rewriting sine squared as 1 minus cosine squared theta, 3 plus 2 cosine theta equals 3 times, in parentheses, 1 minus cosine squared theta, and outside parentheses, plus 1. So we can distribute the 3. 3 times 1 is 3, and 3 times negative cosine squared is negative 3 cosine squared theta. So now that we have this equation, we can move everything to one side of the equal sign. So now we have 3 cosine squared theta plus 2 cosine theta plus 3 minus 1. These terms simplify to negative 1. This here is our final equation before we factor. Now, when we factor, we get 3 cosine theta minus 1 times cosine theta plus 1. Now, we set each of these equal to 0. So we have 3 cosine theta minus 1 equals 0, and cosine theta plus 1 equals 0. So, solving for cosine, we get cosine theta equals 1/3 and negative 1. So, coming down to the unit circle, we recognize that negative 1 is an exact value. Where cosine equals negative 1 is this point right here. And the answer to that is pi. That location is pi. Now for 1/3, this is not an exact value and we must round to the nearest thousandths. So to do that, we go to our calculator. We take the inverse cosine of 1/3 and we get 1.230, and that 0 will round up to a 1. So one of our answers will be 1.231, and that is located right here. Now to find this answer right here, we must do 2 pi minus answer. We get 5.052, and that is our third answer, 5.052.
Okay, so for problem B, we have cosine times theta minus pi over 2 equals 1 minus 2 cosine squared theta. So first, we have to do the rap song for cosine, which is cosine, cosine, sine, sine. And so if we remember from the rap song, we have to change this sign right here to a plus. So we have cosine theta times cosine pi over 2 plus sine theta times sine pi over 2. So if we go to our unit circle, we can see that cosine pi over 2 is 0. So we have cosine theta times 0, which equals 0. And then for sine, we can see that sine pi over 2 equals 1. So now it becomes sine theta times 1, which becomes sine theta. Now we add the two together, sine theta plus 0, which equals sine theta. So now we plug our answer into our equation, and we set sine theta equal to 1 minus 2 cosine squared theta. If we remember, cosine squared can change to 1 minus sine squared theta. So now we have sine theta equals 1 minus 2 times 1 minus sine squared theta in parentheses. So now we have to distribute this 2 right here. So we end up having sine theta equals 1 minus 2 plus 2 sine squared theta. And so now we set the equation equal to 0, and to do so we have to get this sign on this side. So we move that over, and then we get 2 sine squared theta minus sine theta minus 1. And so in order to find what sine is equal to, we have to factor this equation. So we end up getting 2 sine theta plus 1 times sine theta minus 1. Now in order to find what these equal, we set both equations equal to 0. And so we end up finding that sine theta equals negative 1/2 and 1. And so we go back to our unit circle and we see where sine equals 1 and where sine equals negative 1/2. And as we can see up here, there is no domain. So our answers, we're going to tack on a plus 2 pi n on the end. And so our final answers come out to be pi over 2 plus 2 pi n, 7 pi over 6 plus 2 pi n, and 11 pi over 6 plus 2 pi n. Okay, so now for problem 2b, we have 3 minus 3 cosine theta equals 2 sine squared theta. Now, we have a domain for this problem, so we need to pay attention to that and recognize that. So, our first step is to recognize that we have sine squared. Now, sine squared can also be rewritten as 1 minus cosine squared. So, we change that, and so we now have 3 minus 3 cosine theta equals 2 times, in parentheses, 1 minus cosine squared theta. So now, we have it changed. We have to distribute this 2 right here. So we distribute it, and we have 2 minus 2 cosine squared theta. Now, the equation is 3 minus 3 cosine theta equals 2 minus 2 cosine squared theta. And so, in order to set this equation equal to 0, we have to get all the terms onto one side. So, we move these terms over to this side, and so we end up getting 2 cosine squared theta minus 3 cosine squared theta plus 3 minus 2. And so that simplifies to 2 cosine squared theta minus 3 cosine squared theta plus 1. And so now we have to factor. So we have 2 cosine theta minus 1 times cosine theta minus 1. So now we set these equations equal to 0. So we have 2 cosine theta minus 1 equals 0, and cosine theta minus 1 equals 0. And so for 2 cosine theta minus 1, we get cosine is equal to 1/2. And for cosine theta minus 1, we get cosine is equal to 1. So now we look to our unit circle, and we see that we have cosine is equal to 1, and so we look to see where we can plot that. And that's at 0 and 2 pi. However, if we look at our domain restriction, we see that the answer cannot be equal to either 2 pi or 0. So those answers we cannot use. And now we look at cosine at equals 1/2, and so we look to see what that can be equal to. We see in the first and fourth quadrants, we have pi over 3 right here, and 5 pi over 3 right here. And so since those fall within our domain restriction, those are our 2 answers for this problem.
Alright, for this problem here, we have sine times, in parentheses, pi over 2 plus theta equals 2 sine squared theta minus 1. We must notice this as a rap song, in which we can write it as sine cosine plus cosine sine. So now we have sine pi over 2 times cosine theta plus cosine pi over 2 times sine theta. Moving to a unit circle, we recognize that pi over 2 is this location right here. So the sine of pi over 2 is 1, and the cosine of pi over 2 is 0. So 1 times cosine is cosine, and 0 times sine is 0. Therefore, we have cosine of theta plus 0, and that equals the cosine of theta. Now we can continue with our problem. Next, we must recognize that sine squared theta can be written as 1 minus cosine squared theta. So we now have cosine theta equals 2 times, in parentheses, 1 minus cosine squared theta, and outside of the parentheses, we have minus 1. So after distributing the 2, we now have this equation, and can move everything to one side of the equal sign. We now have this equation, 2 cosine squared theta plus cosine theta minus 2 plus 1. These two terms here simplify to -1. This is our final equation before factoring. Once we factor, we have 2 cosine theta minus 1 times cosine theta plus 1. We then write each of these as individual expressions equal to 0. So we have 2 cosine theta minus 1 equals 0, and cosine theta plus 1 equals 0. Cosine theta in this expression is equal to 1/2. And cosine theta in this expression is equal to -1. So now we move to the unit circle. And before we begin, we must recognize that there is no domain restriction. This means that each of our answers will be followed by plus 2 pi n. Starting first with cosine theta equals 1/2. Cosine theta is equal to 1/2 at two locations, one here and one here. Because there is no domain restriction, we can write these two answers as one answer, which is represented by plus or minus pi over 3 plus 2 pi n. You cannot write your answer in this form if there is a domain restriction. Now to the next location, cosine theta equals -1. -1 on the unit circle is this location here, and that is pi. So our second answer will be pi plus 2 pi n. Alright, for this problem here, go ahead, pause the video, do your best, and try and solve it. Okay, now that you're back, let's go over the work and answers. Alright, there we go. Okay, once again, for this problem, pause the video, use what you learned, and try and solve it. Okay, now that you're back, let's go over the work and answers. Alright, there we go.